Before we dive in, make sure you watch until the very end, because what you're about to hear starts as a simple what if, but ends with something that could completely break our understanding of the universe. What if a black hole spins faster than it's supposed to? Faster than physics allows? Faster than reality itself can handle? Imagine an object so extreme that even the laws of the universe start to glitch around it, no longer just bending space and time, but tearing at the very rules that define existence. Sounds impossible, right? That's because according to everything we know, it is. But what if, somehow, it wasn't? Black holes are already among the most mysterious objects in the universe. They form when massive stars collapse under their own gravity, compressing matter into an infinitely dense point called a singularity. Around that singularity lies the event horizon, the boundary beyond which nothing can escape, not even light. But not all black holes are the same. Some of them spin, and when they do, they drag space-time along with them in a phenomenon called frame dragging. The faster they spin, the more extreme this effect becomes. There is, however, a limit. A hard boundary defined by physics. This limit is tied to something called the Kerr solution, which describes rotating black holes. According to this theory, a black hole spin cannot exceed a certain value relative to its mass. If it did, something strange would happen. The event horizon would disappear. And without an event horizon, the singularity inside would be exposed to the rest of the universe. This is where things get uncomfortable, because a naked singularity isn't just another exotic object. It's a direct challenge to the rules of causality. In simple terms, it could allow effects to happen before their causes. It could create regions where time loops back on itself. It could even make the future influence the past. The universe, as we understand it, relies on cause and effect being consistent. Break that, and everything becomes unpredictable. That's why physicists believe in something called the cosmic censorship hypothesis. It's the idea that nature hides singularities behind event horizons, preventing them from affecting the rest of the universe. In other words, even if singularities exist, we're never supposed to see them. They're censored from reality. But let's ignore that for a moment. Let's imagine a scenario where a black hole is somehow forced to spin faster and faster. Maybe it absorbs matter with extreme angular momentum. Maybe it merges with another rapidly spinning black hole in just the right way. Or maybe some unknown process pushes it beyond its natural limit. At first, nothing unusual would seem to happen. The black hole would spin faster, its event horizon flattening slightly at the poles and bulging at the equator. The region around it, called the ergosphere, would grow more intense. This is the zone where space-time is dragged so violently that nothing can remain stationary. Everything is forced to move in the direction of the spin. But as the spin approaches the theoretical maximum, the structure of the black hole begins to change in subtle ways. The event horizon becomes thinner, more fragile. The boundary between inside and outside becomes less defined, almost like a stretched membrane on the verge of tearing. And then, if the limit is crossed, the impossible happens. The event horizon vanishes. Suddenly, the singularity is no longer hidden. It is exposed, naked, sitting in the fabric of space-time with no barrier to contain it. And this is where the real chaos begins. Near a naked singularity, the normal rules of space and time break down completely. Paths through space-time, called geodesics, can twist and loop in ways that are normally forbidden. Light could orbit infinitely or escape in unpredictable directions. Objects falling toward the singularity might never actually reach it, or they might emerge somewhere else entirely. Even more disturbingly, closed time-like curves could form. These are paths that loop back in time, meaning an object following one could return to its own past. Imagine sending a signal into such a region and receiving the reply before you even sent the message. Or worse, imagine an event causing itself with no clear origin. This isn't just science fiction. These are real mathematical solutions to Einstein's equations under extreme conditions. Now here's the question that keeps physicists awake at night. If such a thing were possible, why don't we see it? Why hasn't the universe already broken itself? One possibility is that it simply can't happen. That no matter what you do, no matter how much matter or energy you throw into a black hole, it will always stay within its limits. Any attempt to overspin it would fail. The excess angular momentum might be radiated away, or the black hole might shed energy in some other way to keep itself stable. But what if there's a loophole? Some theoretical models suggest that under very specific conditions, it might be possible to push a black hole beyond its limit, at least temporarily. Quantum effects, exotic matter, or interactions we don't yet fully understand could play a role. And if that's true, then naked singularities might not just be mathematical curiosities, they could exist somewhere out there in the universe. Halfway through this mind-bending journey, if you're enjoying this exploration of the impossible, don't forget to like the video, subscribe to the channel, and turn on the notification bell so you don't miss the next deep dive into the unknown. Now, let's go even deeper. If a naked singularity were to exist, it wouldn't just be a passive object. It could fundamentally alter its surroundings in ways we can barely comprehend. The extreme gravitational gradients could amplify quantum effects, potentially creating bursts of energy or particles that don't behave according to known physics. Some scientists have even speculated that naked singularities could act as natural particle accelerators, far more powerful than anything we can build on Earth. They could smash particles together at energies so high that entirely new forms of matter might be created. Studying such processes could reveal hidden dimensions, unknown forces, or deeper layers of reality. But there's a darker side to this. If causality breaks down near a naked singularity, then predictability disappears. Physics relies on the ability to make predictions based on initial conditions. But in a region where the future can influence the past, those predictions become meaningless. You could no longer say with certainty what will happen next, because next might not even have a clear definition. This could have implications far beyond the immediate vicinity of the singularity. If information can escape from it in unpredictable ways, it might spread this uncertainty outward, affecting larger regions of space. The universe itself could become less stable, less deterministic. And then there's the question of observation. If we were to detect a naked singularity, how would we know? It wouldn't look like a normal black hole. Without an event horizon, there would be no perfect shadow, no clear boundary. Instead, we might see strange distortions of light, unusual gravitational lensing effects, or radiation patterns that don't match any known model. It would be subtle but unmistakable to those who know what to look for, a cosmic anomaly, a crack in the rules. So far, all observations of black holes have been consistent with the idea that event horizons exist. The images captured by telescopes, the gravitational waves detected from mergers, everything points to black holes behaving as expected. But our observations are still limited. The universe is vast, and we've only examined a tiny fraction of it in detail. Somewhere out there, beyond our current reach, there could be objects that defy our expectations. And if we ever find one, it would force us to rethink everything. It might mean that our understanding of gravity is incomplete, that general relativity, as powerful as it is only part of a larger framework. It could provide clues toward a theory of quantum gravity, the long-sought unification of the very large and the very small. Or it might reveal something even more profound, that the universe is not as orderly as we believe. That beneath the apparent consistency lies a deeper layer of chaos, waiting to emerge under the right conditions. Before we wrap this up, I want you to think about this and let me know your thoughts in the comments. Do you think the universe really protects itself with cosmic censorship, or could naked singularities actually exist somewhere out there? As we come to the end of this journey, remember that questions like this are what drive science forward. Every time we push against the boundaries of what we know, we open the door to something new, something unexpected, something that might completely change our perspective on reality. And if a black hole could spin faster than theoretically possible, it wouldn't just be a violation of physics. It would be a message, a sign that there is more to discover, more to understand, and more to explore. If you enjoyed this exploration into one of the universe's most extreme possibilities, make sure to like the video, subscribe to the channel, and ring the notification bell so you don't miss the next mind-bending story about the cosmos. Because out there, in the vast darkness of space, the impossible might not be so impossible after all.